So, how did everybody do on part one of the 6.1 classwork? So, hopefully, everything went fairly well. So, in this section, what we want to talk about is how you compare whether one fraction is bigger than another. And we did something similar with integers and with natural numbers. We were trying to, we use number lines and things like that. So, again, we'll do similar things for fractions. We'll use number lines, but we're also going to use our little models as well to help us with that. And then ordering fractions just means to kind of line up a list of fractions from lowest to highest. So let's dive right in and kind of look at the first one. So in this case, it says look at the fraction 3 over 1 and the fraction 1 over 3. Which statement is true? Circle your answer. So is 3 over 1 equal to 1 over 3? 3 over 1 less than 1 over 3? Or 3 over 1 greater than 1 over 3? So hopefully at this point you're shouting out at home that it's C, 3 over 1 is greater than 1 over 3. And then how do we know this statement is true? So again, I'm going to kind of show you both models because this is sort of the typical way we would do it. So first let me show you the number line model. So in this case, 3 over 1 is the same thing as 3, so I want to make sure I draw my first diagram so it goes out big enough. So 3 over 1 is going to live there on our number line. And since we want to graph the fraction 1/3, so again, since the denominator is 3, that means we need to break up this first interval into 3 parts, which means we need 2 lines. So that'll give us 1/3, 2/3. And technically, if we wanted, we could break the other parts up, but since we're only graphing 1/3, which is here, then pretty easy to tell at this point that 3 is bigger than 1/3 because 3 is to the right of 1/3. So that shows us using the number line model. So now if we want to use our rectangular box models, so if I wanted to graph 3 using the boxes, so that means I'd actually have to graph 3 different boxes, and then I'd want to shade in all 3 of those boxes. So this is the same thing as the number 3 over 1. And notice I didn't divide any of the bottoms up because the bottom number is 1, so I don't want to have any, I don't want to partition the boxes or anything. So now if I want to do the same thing with 1 over 3, so again we would draw rectangles the same size, but in this case since our denominator is 3, we'd want to partition it up into 3 boxes, so we need 2 lines, and I'm only shading one of them. So again this gives me 1/3. So again it's pretty clear based on the picture that I can tell that one is much bigger than the other. So there's also some cool apps that you can either get on your phone, or there's ones that you can do on the computer too. So let me show you that real quick. So the one I'm using is what's called Fraction Strips. So let me clear this out real quick. And so with this one, I can kind of turn on my number strips over here, and so I can show what the different blocks are. So for example, if I wanted to compare 3 to 1/3, I can actually grab 3 of these whole strips, and then again I can grab a 1/3, and I can line them up side by side, and again it's pretty clear that 3 is much bigger than 1/3. So I'm going to go back and forth and use this every once in a while to help us display things. But again, this is kind of a cool app. It's very nice for students to be able to manipulate the actual fractions to compare. And this one's got another cool feature. Since we just talked about equivalent fractions, if you take this arrow at the top and you move it, notice every time you get to an equivalent fraction, it highlights those 2 equivalent fractions. So in this case, 1/4 and 2/8 are equivalent fractions. 1/3, 2/6, and 3/9 are equivalent fractions. 1/2, 2/4, 3/6, 4/8, 5/10. And so you can kind of keep going, and every time you get to an equivalent fraction, they both pop up. So again, this is kind of a cool app. It's free, so if you want to play around with it, feel free to download it. If you can't find it, let me know. I can let you know exactly what it's called. So otherwise, let's go back to the notes. So I'll let you guys do 2 and 3. So again, at this point, pause the video, practice 2 and 3, just like we did above. So if it asks for a model, either think of the number line or the rectangles, or again, if you want to play around with those number strips, you can do that. So again, here's a nice, for number 4, this is a nice one where the number strips come in handy. It's saying to compare without using common denominators, which one of these guys is bigger. So just looking at 5/6 and 3/8, I might not have any idea at all which one's bigger. So what I'd want to do is, either graph them on a number line, or again, using like the number strips is a nice, cool way to do it. So let's do the number strips, just since we've got the app. So in this case, let me turn back on the numbers here. So I want to do 5, 6. So let me grab the 6's. So let me pull 5 of these out. And then below it, I wanted to do 3/8. So by looking at the number strips, I can see that the 5/6 is definitely a lot bigger than the 3/8. So in this case, it looks like 5/6 is bigger than 3/8. So let's flip back to our notes. So that means we can jot our inequality that way. And so again, and what you could do down below is just the same thing. Now that we saw what it looked like, we could actually draw this out. So in this case, we'll draw 2 rectangles that are the exact same lengths. And the first one I want to divide up into 6 parts. So I need 5 lines. So 1, 2, 3, 4, 5. And again, my last one's a little bit bigger, unfortunately, but I'll try to do better on the next one. So the next one I want to divide up into 8 parts. So I need 7 lines. So I need 1, 2, 3, 4, 5. Whoops, I did the wrong lines. Hold on, let me fix this real quick. Thank goodness they made erasers for these things. Oops, didn't mean to blow it up. 1, 2, 3. 1, 2, 3. So again, the first one, I'm going to shade 5 of these guys. And the bottom one, I want to shade 3. So even though my drawing's terrible, I can still see that the 3/8 is much, much smaller than the 5/6. So last, what we want to do is they want us to compare these using common denominators. So the first thing we'd have to do is actually find a common denominator between 6 and 8. So worst case scenario, if you're not very good at finding common denominators, you can always just multiply 6 times 8 together and make that the common denominator. It may not be the smallest common denominator, but it's going to be a common denominator. So in this case, 24 would technically be the smallest, but if you have trouble finding the smallest common denominator, it's okay. Just multiply the 2 bottoms together, get the common denominator that way. So I'm going to do it that way just to demonstrate. So what I need to do, so to turn the 6 into a 48, I had to multiply that by 8. So that means I need to multiply the top and the bottom both by 8. And then for the 3/8, to get 48, I had to multiply the top and the bottom by 6. So in this case, I'm going to get 40 over 48, 18 over 48. And the nice thing is, when you're comparing 2 fractions that have the same denominator, you can really just ignore the denominator and look at the top numbers and say which one of these is actually bigger. Is 40 bigger than 18, or is 18 bigger than 40? So in this case, since 40 is bigger than 18, then 40 over 48 is bigger than 18 over 48. Does that make sense? All right, good. So pause the video at this point. Go ahead and work on 5 and 6 for me, so you can do the same thing. Again, you can use the little fraction strips, you can use the pictures, use the number line, whatever it helps you to make sure you understand these guys. And then when you're done that, come back and we'll do number 7. All right. So for number 7, so again, all they want us to do is compare these fractions, try to figure out whether they're less than, greater than, or equal to. So again, feel free, you can do these any of the ways that you want. You can use the fraction strips. So we can use the number line, or we can use the common denominator. All 3 of them are going to work, so it's up to you which one you'd rather do. So in this case, if we look at 1/3 and 1/4, just because I like this app, I'm going to jump to the app real quick first. So again, just to get kind of a baseline. So in this case, let me pull my 1/3 out. Let me pull my whoops. Oh, don't put it on top of it. And so again, if I look at my picture, 1/3 is bigger than 1/4 on my little fraction strip. So 1/3 would be greater than 1/4 in this case. But again, if you wanted to use this doing common denominators, again, what we could do is we could take 1/3, multiply top and bottom by 4, and get 4/12. And then take 1/4, multiply top and bottom by 3, get 3/12. And again, since 4 is bigger than 3, that means 4/12 is greater than 3/12. So again, I'll leave the rest of these for you guys. Pause the video at this point, work through the rest of them. Play around with different models just so you get a chance to experiment with each kind. And when you're done with those, come back to the video and then we'll finish up this lesson. Okay, so for number 8, it says plot the following fractions on the number line in such a way that each number falls on a tick mark. The tick marks should be evenly spaced. So the best way to do this is we really do want to get a common denominator for all of them. So that way we can actually get the same tick marks for each one of them. So what we're going to want to do is write each of these fractions in an equivalent fraction form. So in this case, since 12 is our biggest denominator, let's look and see if 12 would actually be a good common denominator for all of these guys. And so since we've got a 3, a 4, and technically 1 is just 1/1, 12 actually would be a good common denominator for all of these. So what I'm going to do is first rewrite all of these in their equivalent fraction form. So 5/3, if I wanted to have a 12 denominator, means I need to multiply the top and bottom by 4. So that's going to give me, 15/12, sorry. And then 7/4, I want to multiply top and bottom by 3. So that's going to give me 21/12. And then remember, 1 is always just the same thing as 12/12. Okay, so now what I want to do is go ahead and start dividing this guy up into some intervals. So in this case, let's see how far we're going to have to go. Looks like I should be able to stop at 2. 2 looks like I shouldn't have to go much bigger than 2. And so I'm going to put a 2 out on the right, and then a 1, hopefully somewhere in the middle. So again, since we want our fraction to be 12, we want 12 blocks in the number line, so that means I'm going to need 11 tick marks. So it means I'm going to get 1 right in the middle, and then 5 on each side. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then same thing up here, divide it in half. And 1, 2, 3, 4, 5. 2, 3, 4, 5. That was pretty terrible, but again, you get the idea. So now if we were to go through and write out all these tick marks, so this would be like 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7, 6, 9, what am I writing? 6/12, 8/12, 9/12, 10/12, 11/12, and then 1 would be 12/12. And I kind of keep going from there. So let me go ahead and see if I can plot some of them right away. So 12/12, I can plot, it's going to be right there. So 15/12, 21/12, and 17/12. So it looks like I still need to keep counting. So in this case, the very first one will be 13/12, 14/12, 15/12. So there's that one. And so this, remember, is the same thing as 5/3. So 16/12, 17/12. So that's going to go there. And then we've got 18/12, 19/12. Oops. 20/12. And then finally 21/12, which was the same thing as 7/4. So again, with that guy, like, all you're trying to do, get the common denominator first and then order them from there. So 9, I'm going to let you do the same way. So again, the easiest way to do that would be to get a common denominator for each of them. Or you could even do the number strips, like that would be a fun way to do it. And then try to figure out which one comes first. So 10, so again, what we want to do, same thing, we want to order these guys from least to greatest. So this one is actually a very nice one to use with the number strips because it's pretty clear right away which ones are bigger, which ones are smaller. So I'll leave 10 for you as well. So, but if you do have questions about any of these, definitely ask. I'll be around the computer all day tomorrow. So hopefully you do well on this, and that's the end of 6.1.